here's something interesting to consider. Is there any way that you can make the inverse of a function, which is not a function, into a function? Oh my God, yeah. Well, actually, yes, there is a way. The way you do it is you restrict the domain. That's how you do it. What do I mean by that? Okay, well, first things first, let's go out and graph this thing, which I already did for you right there. I did a really nice little cool little graph for you. And then I'm going to tell you that, okay, I'm going to want to draw the inverse of this function. Okay, so I want to see the inverse of this function. Well, let's start taking some points. Here's a point here, which is 0, 3. The inverse of this, of course, is going to be 3, 0, right there. Perfect. Okay, now, take a look at this. Find me another point. Well, the x-intercepts aren't nice, but I found a point here and a point here that look very pretty. So, okay, let's use them. -1, 1, and 1, 1. Okay, so let's find the inverse of this. The inverse of this guy is going to be 1 minus 1. So 1 minus 1, which is going to be out here. And I'm going to use red. 1 minus 1, there's the inverse of this point. And the inverse of this point, oh my goodness, is still 1, 1. Oh, so in other words, this graph is going to come around this way and go in that direction. Okay, fine. But if you do a vertical line test, you'll notice that the inverse is in fact not a function. Because watch, vertical line, da-da-da, cuts twice, not a function. Okay, but is there a way of restricting this so that you can actually show that parts of the graph are a function under a certain restriction? Huh? What does that mean? Okay, real simple. Let's determine the inverse of this first. Okay, let's determine the inverse of this first. So we've got y equals to minus 2x squared plus 3. You know and I know you have to reverse this. This becomes x equals to minus 2y squared plus 3. Now, here's what we're going to do. Subtract the 3 from both sides. So you got x minus 3 equals to minus 2y squared. You're going to divide this by minus 2, divide this by minus 2. This is going to give you y squared equals to minus 1/2 x minus 3. And then you're going to square root this and square root this to give you y equals to plus or minus the square root of minus 1/2. Oh my gotcha, x minus 3. This is ugly, isn't it? Okay, now the cool thing is you got to remember which one's which. If this is positive, what part of this graph here, the inverse graph, are we talking about? Well, if we're talking the positive one, we're talking the upwards one. Okay, that's kind of cool. Where did that come from? Well, where did that come from? It's really, really easy to see. The positive value of this, let's just go out and draw it. Look, this function here is a result, surprisingly enough, of the reflection. Let's draw on the reflection line, which goes right through here like this, y equals x, right? There's a reflection line. Think about this. This guy, count, 2, 1, 2, goes to here. Perfect, equal distance, right angle, right? Look at this point here, right? This point, oh yeah, this point right here. 1 over, 1 over. There it is. So this point actually is this point. So that means we're talking about this side of the graph. So if we actually say x is less than or equal to 0, so in other words, starting here and going this way, we're talking about this side of the graph. There's a restriction. So if I only want to talk about this side of the graph, and I'm going to get this here as my only inverse. See what I mean? So I'm not talking about this side. I'm not talking about this side of the graph. I only want this side of the graph. I now know that my inverse is going to look like this. So there's my restriction. I'm going to say up to this vertex and this way. So I'm using the vertex as my starting point for this. So there's my restriction. So if I only looked at x less than or equal to 0, meaning I'm going in this direction here, right? That means I'm only going to get this portion of the graph. So if that is, what is the restriction on the domain? So the inverse is a function, let x be less than 0, and then I'm just going to have the positive portion of this graph, right? Cool. Now, What if I want the other portion of this graph? Well, if I want the other portion of this graph, which is this section down here, right? Think about it. Let's map this. Okay, this still goes maps to this, but let's take a point here, okay? And look at that. I'm going to map this, or actually better yet, let's map this to this point right here. Perfect. I'm looking at the negative portion of this graph because this course is opening downwards. So from the point here, positively, x being greater than equal to 0, I'm looking at this negative portion of the graph, negative square root of minus a half x minus 3. There's my restriction, making, if I'm only talking about the bottom half, I can do vertical line tests all day, and that's a function. If I'm only talking about the upper portion of the graph, I can do vertical line tests on the upper portion. That's a function now. But remember, if I put two of these guys together and I get this beautiful graph going in this direction, a vertical line test tells you it's not a function. So by restricting the domain, I can actually make this into a function. Kind of cool.